I am Janupra Kalita, Assistant Professor in the Department of Mechanical Engineering, Tezpur University. Introduction to Mechatronics. Outline of the presentation. What is mechatronics? Elements of a mechatronic system, microprocessor-based spring mass system, importance of mechatronics in manufacturing automation. What is mechatronics? Mechatronics is a concept of Japanese origin adopted in the 1970s. It is defined as the application of electronics and computer technology to control the motions of a mechanical system. Mechatronics comes from the two words that is mechanism and electronics. Any mechanical system which is automated is known as a mechatronic system. Mechatronics is a multidisciplinary approach to product and manufacturing system. It involves the application of electrical, mechanical, control and computer engineering. In order to design a mechatronic system, it is necessary to have the knowledge of all the different disciplines of engineering. So it concurrently includes all the four disciplines. With the help of mechatronic systems, various products, processes and systems are developed with greater flexibility, and redesigning and reprogramming of a system can be done easily. Mechatronics is widely used in our day-to-day lives. It is used in home appliances such as washing machines and dishwasher. It is also used in modern automobiles in which the mechanical fuel injections are replaced with the electronic fuel injection systems, leading to less pollution. It is also used in four-wheel passenger automobiles where there are airbags, parking sensors, anti-theft electronic keys. It is also used in the automation of manufacturing industries. Elements of a mechatronic system. A mechatronic system can be thought of as a box which has an input and output elements, and a set of relationship exists between these elements. Say for example, if we take a spring mass system, the input to the system will be the force and the output to the system will be the extension, that is the displacement, and the system will follow the Hooke's law, that is F equal to minus kx, where F is the force in Newton, x is the distance in meter, and k is the stiffness of the spring. So this block diagram shows a mechatronic spring mass system where force is the input and displacement is the output. Elements of a mechatronic system. The mechatronic system integrates various technologies involving sensors, measurement systems, drives, actuation systems, microprocessor systems, and software engineering. So this figure shows the components of a mechatronic system. The first is the mechanical system, then is the sensor, then we have the converter, then the microprocessor, then the converter again, then the actuator, and finally the microprocessor. To replace the mechanics of this mechanical system with an equivalent mechatronic-based system, the basic controlling element, a microprocessor, is required. A microprocessor processes or utilizes the information gathered from the sensor system and generates the signals of appropriate level and suitable kind, which will be used to actuate the required actuator, for example, a hydraulic piston cylinder for extension of the piston rod. The microprocessor is programmed on the basis of the principles of Hooke's law. So this is the schematic of the microprocessor-based equivalent spring mass system. So the hydraulic piston cylinder system is a mechanical system. The strain gauge is a sensor which will sense the force. The signal from the sensor will be sent to the signal conditioning device. From the signal conditioning device, the signal will be sent to the analog to digital converter, then to the microprocessor. Then the signal will be sent to the digital to analog converter, and finally it will be sent to the actuator and back to the hydraulic piston. The input to the system is a force which can be sensed by suitable electromechanical sensors, that is the piezoelectric device or the strain gauge. So these sensors generate either digital signals or analog signals. So these signals are then converted into right form and are attenuated to a right level, which can properly be used by the microprocessor to generate the actuation signals. Various electronic devices such as ADC, DAC, op-amps, modulators, linearization circuits are used to condition the signals which are either received by the microprocessor from the sensors or are sent to the actuators from the microprocessor. This mechatronics-based spring mass system has the input signals in digital form which are received from the ADC and piezoelectric sensor. The digital actuation signals generated by microprocessor are converted into appropriate analog signals. So these signals operate the hydraulic pump and control valves to achieve the desired displacement of the piston rod. Importance of mechatronics in manufacturing automation. Today's customers are demanding more variety and higher levels of flexibility in the products. So due to these demands, the competition in the market, manufacturers are striving to launch new or modified products to survive. So mechatronics can be widely used for manufacturing automation. So these are some of the applications in manufacturing automation, which are flexible manufacturing systems, computer numerically controlled machines, tool monitoring system, and industrial robots. Thank you.